Today is to look at trig functions using a point, and these are points that are not on the unit circle. They are usually points that are further out than what the unit circle goes, has a radius bigger than 1. So what we want to look at, finding the 6 trig functions of an angle passing through this point, -3, 4. What we should be doing is looking at a coordinate plane. Where would the point -3, 4 be? What quadrant would it be in? Well, x is negative, y is positive. It would have to be somewhere up here, this point -3, 4. What I want to do is I need to draw that angle from the origin. What I also want to do then is draw a triangle and make it a right triangle. Now, do I go to the right towards the y-axis or down towards the x-axis? Just like using a reference angle, always go down or up, whatever direction, to get to the x-axis. Now you've made your triangle. Theta, always, always, always goes at the origin. Now you want to make your side lengths. Which is which? Well, -3 was your x value, so I should be going in the negative direction, and that should make sense. I'm going to the left. My y value is 4, and I need to figure out what my hypotenuse is. I can do that with Pythagorean theorem. -3 squared plus 4 squared will give me my hypotenuse squared. Well, this gives me 25 for c squared, which means my hypotenuse here is 5. Once I get that, I can then find all my trig functions. So, sine of this angle, this is just SOHCAHTOA. Opposite over hypotenuse, so 4 over 5. Adjacent over hypotenuse for cosine is -3 over 5. And tangent, opposite over adjacent, 4 over -3. At this point, I want to check my answer. This point we said was in quadrant 2. Remember we said last class we had all students take calculus. In quadrant 2, the only thing that should be positive is s, sine, which it definitely is. That's the only one that has a positive there. Then to find the other 3, I just need to flip all of these. So 5 over 4, -5 over 3, and -3 over 4. Just like that. All right, here's another example. See if you can solve this one. I would suggest pausing the video, seeing if you can find all 6 trig values. All right, let's see how you did. You should have picked your point down here somewhere because it's -5, -12, put you in quadrant 3. I would even say right off the bat, as you draw your triangle, make sure you go up to the x-axis. Because I'm in quadrant 3, the only thing positive in quadrant 3 should be tangent. I can even remind myself of that by making then everything else negative, and then cotangent and tangent should be the exact same. That can kind of help you as you go along to make sure that you're doing everything correctly. Okay? Theta goes at the origin, just like we did before. -5 is your x value, -12 is your y value. To figure out your hypotenuse will always be positive. Your hypotenuse here should be whatever -5 squared plus -12 squared is. In this case, they add up to 169 for c squared, which means I should get 13 for my value of c. So this hypotenuse is 13. So now I can just use my, my trig function, my SOHCAHTOA. So sine should be opposite over hypotenuse. It's -12 over 13, and that is negative like we needed. Cosine, adjacent over hypotenuse, -5 over 13, again, just like I wanted. And tangent, opposite over adjacent, -12 over -5. Well, -12 over -5, well, negatives will cancel out, so it should just be a +12 over +5. And then same thing, flip everything around to get your other values. 13 over 12, 13 over 5, and 5 over 12. All right, there's one other kind that we can get. Instead of being given a point right from the beginning, they could give us even a trig value right off the get-go. They even give you this answer, 5 over 13, to start with. Now, what we're going to do, same thing, draw a coordinate plane and see where we could go. Well, what we should look for here, sine is positive. What quadrants does that mean it could be in? Well, everything's positive in quadrant 1, and sine is also positive in quadrant 2, so those are my only options. Now, for this part here, this tells us what we need to narrow it down even further. Cosine is positive in 1 and then in 4, but we want it when it's less than 1. So we want to know when it's negative, which would be 2 and 3. So my only possibility is then in quadrant 2. That's where my function, or where my point is where it would have to be, right in here. So draw your right triangle like we've done before. There's theta. And what I should look at, if sine of theta is 5 over 13, that means the opposite is 5, and the hypotenuse is 13. What we can do from there is do Pythagorean theorem to find the missing side. 5 squared plus this missing side squared equals 13 squared. When I do that and subtract, I should get b squared equals 144, which means b will equal 12. The question is, though, is that a positive 12 or a negative 12? Well, there's a couple ways to figure it out. The main thing I would look at, though, I'm going towards the left. My x value needs to be negative at that point. The other way I could have figured that out, if I left this positive, when I did cosine, I would have gotten 12 over 13. But cosine, we said, had to be negative. So I can say right there it has to be negative as well. Tangent, opposite over adjacent, 5 over negative 12 or negative 12 over 5, either way. And then all I have to do is flip them when I do the other way. Negative 13 over 12, negative 12 over 5. And again, check and make sure. Quadrant 2, the only thing that should be positive is sine, which it is. So that's how you know that you're in good shape. And that's how you can find them using any point, even if it's not in the circle.